Name of the game. Do I have an equation? If yes, cool. If not, figure it out. Number 2, let's say we have an equation. Who are all the players? Who are all the variables? What are all the different pieces? What's unknown that I need to find? Step number 3, okay, what have I been given? How do I use it? How do I plug it in to solve for what's missing? Now, guys, real quick. If we were to go, let's see which place we can go right now. Precalc graphing handbook from the beginning of the year. Okay? Precalc graphing handbook from the beginning of the year. Didn't you have calculator worksheet number 2 that was basically all word problems? Okay. And with all of those word problems, weren't there times where you would find a regression? You would find a regression from like a scatter plot of points. What's a regression look like? An equation. Right? The scatter plot was the weird zoom stack and all that jazz, but the regression was a linear regression, a quadratic regression, a cubic regression. If you want, you can go look at your worksheet. Sorry, it was musty. I was trying to air it out. Guys, you're in the hallway. Thank you. They're cute. They were just, I don't know, singing happy middle school songs. Anyway, a regression would be an equation. But then there were parts, if you guys remember, you were super annoyed by it, but it's okay, you made it through, built character or something. You had like an A and a B and a C and a D. And there were different things like find when the population would reach this, or find what the projected cost would be if the demand was, I don't know. They give you a clue, you plug in the clue, and you solve for the unknown. Okay. You're going to see some weird variables. And one equation of that is PERT. That's the one you already have to memorize for your test, right? Here's the hard part. What's y? Exactly. There's no obvious y, but there is something that's in the y spot. And what's in the y spot? A. So couldn't I, instead of saying f of x or y, couldn't I say a of function notation? Well, if A is the y, he's like the f of x. He's like the y equals. Who's my x? T. So ideally, I don't stress about having an unknown A. I don't stress about having an unknown T. Who are the guys that I want to try to plug in for this? Because we have equations with y's and x's. No stress. Give me an x, I'll give you a y. Give me a y, I'll give you an x. I don't mind the a being unknown. He's my y. I don't mind the t being unknown. He's my x. But what guys do I want? P and R. Why not E? He's a variable.
Because it's a number.
2.7182, just a number. No stress. But if I know P and if I know R, then I have my nice little regression, my nice little model equation that I can use to do whatever they want me to do. So, hold on. When we were doing this yesterday, here's the equation that we used. The reason we used it is because it said continuously compounded interest. Last night, a few people were working on homework, or yesterday in class, and they saw that not all finance stuff is continuously compounding. There is another equation that has to do with if you see the word annual, or if you see the word monthly. Formulas to end. That was really weird. Does annual have two ends? Even that looks weird. Easy.
Orderly.
When n equals 1, or 12, or 365. There is another equation. Kurt is not the only finance one. He's just the one that I said we need to memorize. But anyway, in homework, just keep an eye out. There is another equation you might have to use sometimes. But coming back here. We had our model. Check. It said continuously compounded. I'm using Kurt. What was I doing next? I was plugging in what they gave me. I wanted P. Whew, at least they gave me P. I was able to plug in the initial amount. But what else do I want based on what we just saw? I want R. Without R, I can't be given a time and solve for an A, be given an X and solve for a Y. I need to fill in that R. But the problem is, what's true about the blank? It's missing. So if I can't plug in an R, I go looking for other clues and what they might tell me. Guys, this isn't a radius. Calculus are doing radii. This isn't a rate. This is a time, right? So time goes in the time spot. Okay, fine. I didn't know what else to do. Time goes in the time spot. Well, hold on. Wait a minute. That's not enough. Now I'm missing R and A. Whoa. How'd she fill in 1,500? Might be what I thought so.
Because it says time to double.
It says time to double. Doubling this guy would be 1,500. If the initial was 500, doubling it would be 1,000. If the initial was 2,000, doubling it would be 4,000. I took the clue and said, that's how much time T it takes for my amount in my account to be double what it was. Now it's like, sweet, let's solve for R. How? Ready, set, calculators. Can you do it all in one punch-in in your calculator? It'll save you time on the test. What would you punch into your calculator to solve for R? Now, some of you need to do step by step, I know, but some of you, I know, are completely capable of going straight to what R equals. What's the first thing you would do? Divide. Some of you are like, duh, it's 2, it's double. Cool, that's actually a really good skill to have. But whatever, divide. Once I divide, what's left?
So we do natural log.
So I do a natural log. And once I get rid of the e, what's left?
It's R times.
Make sure you stop the ln before you divide, or else everything's going to be all kinds of messed up. Now, were there step-by-step steps? That sounds really good. I apologize. But were there steps that needed to be followed for you to get there? Yes. Can some of you do that in your head? Yes. But here's a quick warning. On a long answer on a test, I've already told you one of these is a long answer on the test, right? We're going to start by it yesterday.
Yeah.
On the long answer on the test, you want to put all your eggs in one basket and go from here to here with a decimal and be like, I'm right.
No.
If you're wrong, can I give you partial credit if all I see is a wrong decimal?
Nope.
So show me the work, that way I can give you partial credit if something little goes wrong. What'd you guys get for your R?
0.08.
Someone back anything up. Can't just go on the word of one. Yeah, cool, good. Wait a minute. They don't want the decimal, they want a... So the first box I can fill in is R is equal to 8.94. But guys, there are 2 unknown boxes. So how do I figure out the amount in the account after 10 years? Plug in what?
R.
I have my P, he's right there. I have my R, I just found him, plug in the decimal, not the percent. And then I know my, plug and chug, that's easy. Once you figure out those unknown quantities, like I just talked about with the whole like R and P thing, once you have those, you can use that equation to do whatever the heck they want you to do. So it's like, sweet, I have that, and I have 0.08.
Why does the time equal 10 years? Like, where's...
Just because they told me.
Oh,
it could have
okay.
been an amount after 20 or 30. Yeah. So, for that one, all I have to do is say, it's time to plug in 10. It's kind of like you have your equation with your y and your x, and you're like, sweet, I can solve for whatever you want. And guys, if you notice, is there a lot of like, I don't know, rearranging, moving, solving, doing algebra? For this one? Nope. Just plug it in your calculator and say, dun, 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 dun. So the amount after 10 years, if we were to solve for it, it's in money because that's the label for the amount, would end up being, few people plugging in. Okay, word to the wise, if you guys don't have a calculator out, it's going to be a rough day because this is definitely a calculator homework. Wait a minute. What does that mean you're allowed to use on the test?
Calculator.
Oh, I've been saying decimals all along, that you can do the decimals and make it match, right? Yeah, calculator's allowed to be used on the test. What do you have?
5,723,397.792.
Round it to the nearest cent. Someone back him up, because that's weird. Me, I'm not saying you're wrong.
I don't know if that's right.
$750 doesn't usually become $5 million in 10 years.
Yeah.
Anybody? What'd you get?
That would be so little.
That seems to make a lot more sense. Nathan, double check. Was this whole thing in your exponent? and it was 0.08, not
You
8.94.
probably raised the whole thing to the 10th power.
0.08.
Oh, okay.
There you go. Ah, your account had an 80% interest return, which would be nice. It's hard enough to get 2%, let alone 80%. This 8% account is crazy. Anyway, can we go talk about half-lives and isotopes? I don't think you guys had 22. I think you had like 24 or something. Does anybody have the number?
21, 24.
And then it goes to a different type of problem, I think. Okay. What could be confusing in this? If this is all that they give you. The isotope name. Come on, who knows who the isotope is though? It's carbon-14, yeah? Okay, so we have carbon. But wait, do we actually need to use 14 in like a math equation?
No.
No, it's the name. Okay, move on. Now what? Half-life. What does half-life mean? How many years it takes for the substance to be cut in, well, not to be cut in, to decay, to be half of what it was, right? Yeah, I won't pretend to know what this is. I was going to go back to like the atomic bomb and like, anyway. Did that region that was hit, Hiroshima and Nagasaki, did they feel the effects of that long after?
Yeah.
Yes. Why? Because those substances take a long time to decay away. Right?
Mm-hmm.
Anyway, carbon-14, how long does it take to be cut in half? It has 6.5 grams. That's the initial amount. It's sitting there. How many years until those grams decay to be half of what they were? 5,715 years. Why is there a thing called carbon-14 dating? Because it sticks around for a long time. Anyway, coming back. So what is this? It's a T. Okay, cool. What's this? It's a P. What? Why are you calling it P? Radioactive decay, interest accounts all follow exponential growth. You could remember PERT for this too. What? But it's getting smaller. That's okay. It still works, and you'll see why in just a second. Now, is there something in the book that might, I don't know, do something like y equals a times e to the bt? Yeah, it could use something else, but do you guys see how it's still, you have a y, you have an x, right? You have an initial, and you have a constant. Like, the same formula. So if you go PERT, that's all you need to know. Because it's decay, something's a negative. I wonder, though, if it'll work out okay, because this is unknown, so I could solve for it to be a positive or a negative, I guess. It could be either one. Huh. What do we plug in? Amount of the isotope. Sure, why not? Equals 6.5 initial, e to the... I really want R, but I don't have it. I'm not plugging anything in yet because I'm setting up my general equation. But I want my R, so what am I going to go doing? Plugging in and looking for it. Good. So I can plug in 6.5 e to the R times 5715. I've left my R unknown because nothing up here gives me R equals. But why did I leave this blank? As though I'm going to fill it in with something. Well, but I need a number here, don't I?
Yeah.
If I have a number here, I can solve for R. Yeah, that's good. But what's the number?
1,800.
Don't go using another clue. That's a whole separate time and amount. I'm plugging in this time. What's true at this time?
Oh, it's half.
It's half. Got him. Does that make sense? They didn't tell me 3.25, but they said it was half of what it used to be. What's the amount of the isotope that's still left? That much. But the cool thing is, even if I didn't know this, but I knew the half-life, I can actually still find R, because what's always going to happen when I divide what it is now with what it was, and I have half-life? Isn't that always going to be a half? Right? Or if it doubles, that ratio will always be 2. Jack, how are we doing back there? Okay. Is that helpful?
Yeah.
With what we're doing currently all together as a class? equations in chemistry where you actually memorize half-life and doubling formulas, or formulas for the rate, I should say, for the rate of change or the rate of growth or the rate of decay. And basically, what ends up happening is it's always ln of 2, which is weird. No, that's ln of a half. Well, I could actually make it ln of 2 with a negative 1, which would come down and end up being negative 1 over 5715. There actually is a formula you can memorize about how the rate of growth or decay from doubling or half-life is going to be ln of 2 over the half-life with a negative, or ln of 2 over the doubling with a positive. Anyway, long story short, Nathan said, like, oh, the rate should be negative. And you're right, it ends up being a negative. You just don't see it until you realize what 1/2 actually does to the value. So there are a couple of different ways of writing it. Most of you would probably just do the decimal. It's not a big deal. But what was I actually supposed to do? Find R! Yeah, but I was supposed to find R to be able to plug in and solve. If you open up your notes and you do the next example with this entire. Okay, so R is equal to negative ln of 2 over 5715, which is good enough for us to go ahead and fill in what's going on up here. But then we have to go ahead and, guys, I'm not going to solve it because, frankly, we have to go to our calculators, and you guys know that takes time. But are we okay to realize that all I have to do, all you would have to do at this point is plug in 1,000? Is that good? Now, some of you are confused. Don't worry. You could have stopped way back here. You're totally fine. I was just showing you why the chemistry formula is what it is. And I was showing you that this rate is negative, which means that this substance is decaying, not growing. But we would throw in that 6.5. We would throw in our negative ln of 2 all over the half-life of 5715, and we would throw in that 1,000. It's a simple plug and chug. Just be careful plugging and chugging. Oh, you got it? Sweet. What do you got?
I got 5.75 or 76.
That seemed to make sense. If it takes 5,000, almost 5.5, or a little bit more than 5,500 years, after only 1,000 years, I mean, yeah, it's not going to decay very much, right? I'm just making sure it makes kind of sense as opposed to that million. But you knew that was weird. You would have double checked that. Yeah? I never crossed that out. Okay. I'm going to go ahead and do a page because some of you guys still might want to get down this whole isotope problem. That's basically how to do that table. It's still exponential. It's just decay instead of growth, but it behaves exactly the same. And if you guys, well, I guess I haven't given you many details besides no PERT. And there's not a lot to memorize from section 3.5. I was doing homework help at the beginning of homework so you didn't have to feel totally stuck as soon as you got to number 7. But remember how I said there were like 5 different models? We've only talked about exponential growth and decay, which is kind of one model, just sometimes it's increasing, sometimes it's decreasing. But we also talked about the money formulas. Let's go talk about the rest of the models real fast. Remember, the graphs, you only need general ideas. Remember, the graphs, you only need the general swoop. There it is. It's going to be helpful for the, I think, the very last homework question. Gaussian, super helpful in statistics and probability and business, in how your grades are curved in college. This is called a normal distribution curve or a bell curve. And a lot of people say, hey, the majority of your class should be C's right here. I think Miss V is kind of teaching you guys that. Or maybe you guys haven't had her yet, but she will when you get her. Average is C. A is supposed to be a very small percentage of your class that is above extraordinary. I think our school system has gotten a little dumbed down. But anyway, college professors get a little bit more back to the traditional. We have Gaussian, we have logistic. Nikki, what's up, kid?
Okay, so after you found R, did you plug it in back to the equation that you made with the initial amount?
Because remember, this is my y, this is my x. I just need my coefficient, and I can use them for whatever they want.
Okay, and I can just plug that into a calculator, right?
Yeah.
Okay.
I just keep it like this because I didn't have to go waiting around for kids to plug it in. And if I found a decimal now and I rounded it now, and I'm using the rounded answer to solve, it's not like sciences where we use sig figs and it's like, just keep it within this the whole time. For these studies, we want to keep it as accurate as possible and as exact as possible, so that technically, to get the answer in the back of the book with the exact same decimals they have, don't run.
Okay.
My way doesn't run.
Answer.
Got it. Or some of you can just scroll up and go steal it from wherever you want. You guys know that? Scroll up and steal either earlier problem or earlier answer. Go forward. Yeah. What's going on? Sadie. At the end of that. Okay, 3 and 4 and 5. Gaussian, logistic, logarithmic. You guys can check in with, we'll check in with John at the end of the year. Logistic growth is going to be not a huge percentage-wise, but it comes back because logistic growth is way more practical than exponential growth. Do you get to see that in your homework? I think we have a flu virus that's spreading. Well, I think literally we have sickness spreading at our school, but in a second we have a problem with the flu virus spreading at a school. And that's going to follow this logistic curve, and we're going to talk about why. Bacteria growth, and that was exponential. Well, it can't go on forever. Emma.
For rate, when we do like up or down, like let's say they do like 5.2 for rate, do you just plug in 5.2? Like they say there's a 5%.
It's a percent?
Yeah.
That's not this.
Okay, so.
So 0.05. Does that make sense?
Yeah.
Bless you. You guys okay? You have the swoops? Okay. The nice thing is, remember how I said you only have to memorize PERT? Do you have to actually memorize these equations in any way, shape, or form? No. I just want you to know the names that go with the general shapes and realize there are general equations you're going to be seeing in homework. Not a lot, because I couldn't give you like, I had to be very specific with what I gave you. And I wanted to expose you to some like extra, oh hey, it's chem, oh hey, it's bio, oh hey, it's physics, oh hey, it's finance. I just wanted to expose you to a little bit just to be like, I'm serious when I'm saying exponential and logarithmic shows up a lot in all these different contexts, all these different applications. But I couldn't give you enough for you to really like go super deep, but this logistic growth equation shows up all the time in bacteria growth, virus growth, population growth, all sorts of different things. This one I already kind of mentioned how it shows up with normal bell curves and distribution, standard distribution, and stuff like that. Statistics is a very commonly required class in college for all sorts of different things like business. There are business stats, anything to do with science, any of the sciences, because stats is super crucial for a lot of lab work, experimentation work, etc. So anyway, you're definitely going to see this Gaussian curve quite a bit. Let's just get to a problem. Dang, that's huge! What are you going to do when you get to a huge problem in homework? Come on. But yeah, let's be honest, that's what a lot of you want to do, right? That's why I asked the question.
So one of those.
So pause. Right? I don't mind the look of like complete and utter disgust, but hold on. Let's see if it's really that bad. What do you see? Give me almost every, well, I'm doing this with Calc AB right now. They're getting paragraphs of information, and the first thing I want them to do is name the problem. Give me a name. What do you see? Online, I would throw in online because it just kind of qualifies from old-fashioned to current. Online advertising spending. Done, right? Okay, so you could summarize that whole entire beginning. Online advertising spending. You could say A, well, wait a minute, there's no A in my equation. Maybe I shouldn't go writing down stuff until I have an idea of what I have. Okay, we have online advertising spending, dot. That's the name of the problem. I would want to do that. We know that it is between 2011 and 2015. We know that it's in billions of dollars. We have a table of info, true? We have a graph, I'm assuming, of that info, but wait, I just see 11, 12, 13, and 14, not 2000. Calculator worksheet number 2 from the beginning of the year. Didn't we say let's just make these 11, 12, 13, and 14 to make our life easier, right? Okay, they did that. They made these into years from 2000. And then they labeled this in billions. Yeah, it's the same stuff, it's just in a table. Oh, or sorry, incorrect. And then they also gave me, did they give me the same info 3 different ways? They did all the work for me. We didn't have to scatter plot. We didn't have to put in lists. We didn't have to get a regression. I don't find a problem that does all the work for me. Now what? Hey, doesn't this say the same thing? S is measured in billions and T is in years? Sweet. I didn't actually need to write any of that. I just need to write this. Right? If you're summarizing the info, that's what I need. Are you sure? Are you sure they don't want us to use the scatter plot? Keep reading, but no. They don't want us to use the table? Keep reading, but not really. Huh, sweet. Online advertising spending equation S colon spending billions T colon years from 2000. I don't like the way they do it. Years from 2000, much more precise. So what are they actually asking? Can you guys read that bottom part?
Compare the value by the model with the estimates shown in the table.
Okay, so tables here, models here is the equation, remember, compare. Wait, wouldn't they be the exact same thing? No. Remember, scatter plots and regressions, do the regressions always perfectly hit every single data point? Or do they just show the general trend? You see it? So they're just saying like, hey, is this a pretty good estimate? To know that, you have to actually plug in 11, how close does it get to 31.3? Plug in 12, how close does it get to 36.8? Could you talk about how close it gets? Yeah. Could you put this in your Y1 and go to your table and actually do like 11, 12, 13, 14, 15 and just look at them and compare? Yeah. But hold on, that's just saying, yeah, it kind of fits. Now what?
One will reach 80 better.
Yeah, this is a huge problem. This must be super hard. Are we missing any of those cool little coefficients we talked about a second ago? No. We're just plugging in. What's measured in billions? Oh, billions. S. Sweet. S is 80. Mm-hmm. This whole page is just telling me to plug in 80 and solve for T?
Yep.
How bad was it? Not at all. But you have to make it through reading it to actually figure out, oh, it's not that. All I have to do is plug and chug. They want me to say, when will this model hit? I just need to find T. How are we doing? Whenever you're taking like a PSAT, that's a thing. Are there big old huge reading comprehension sections? But for one question, do you necessarily need to know every single word that was in that section? Didn't even read them. There you go. That's my strategy. For the math on the PSAT and especially the ACT, more and more they're saying, here's a table, here's a graph, here's an equation, here's a scenario. Can you just analyze what's going on? Seriously. Like, it's a huge trend. All these nationalized tests are like, can you use the data given to you? Why? Because we're in a technological age where tons of data can be thrown at you. Do you know how to not be overwhelmed and strategically, mathematically, critically think through the information properly? Don't get overwhelmed by these. Just take them and do the best you can, okay? Do you need to kind of know math to solve for T? Yes. Unless, okay, ready my ones who are super overwhelmed by the math? Couldn't you make this Y1? Couldn't you make this Y2 and find the intersection? I'm telling you how to cheat in your graphing calculator? Yes. Why? It's a thing, but are you going to have to work with that zoom to figure out where this happens? It's going to be so much work to actually cheat with your calculator. Why not just be like, forget it, I don't want to go zooming to 80 and I don't like all that zooming stuff. Okay, sure. Why not just divide by 9.3 because that's no big deal. Undo the E because that's no big deal. And then divide by your 0.1129. But for just a few of you, I know, I went fast, I apologize. I just want to show you how, if you get the hang of it, it's going to happen the same way every time. We could have actually gone step by step, using our algebra, Yes, you can plug a million things into your calculator and hope that you don't lose a decimal or this or that or the other. Or you can just keep it all nice and contained to where you don't make a mistake. Just please, please, please close that natural log parenthesis before you divide. Or else, once again, you're going to have so many things go wrong. What'd you get, Nathan?
19.06.
Only half, well, 1/3 is not getting overwhelmed, reading, understanding the problem to some extent. 1/3 is solving it mathematically, and 1/3 is saying, what does that mean? They're saying when. Oh, T is 19.06. You sound dumb. When's it going to happen? In 2019. Does that make sense? Got it.
July.
No, not July. It's
Isn't it?
0.06. That'd be January. No, what?
Oh,
See it? Assuming they're measuring from January. I actually know. So I kind of made it up, but I assumed they were measuring from January. Such a huge problem, and yet it wasn't bad. Let's see another one. Hey, this isn't bad. There's no scatter plot. There's no random table, which we didn't have to do anything with anyway. There's, very timely, a virus going around a college campus. The college campus only has 5,000 kids. Wait, that equation, it looks like something. What does that look like? Which one? Yeah, close. Logistic.
Yeah.
Logistic growth. Why would this make sense? Why would it be like growing, growing, growing? Just kidding, slowing down.
because it can only grow.
It can only grow. Exactly. It can only go up to. Do you guys know what the horizontal asymptote would be for this guy? 5,000. Why? There are only 5,000 kids. What about the staff and the commuters? Stop. Security personnel? Stop. Keeping it basic. But there's only 5,000 kids. This kind of happens in like population growth of animals too, like on certain, I don't know, let's use bunnies because they reproduce like crazy. If you like throw a few bunnies out there and they all start reproducing, how long will they last?
A long time.
Until they eat up all the environment and then they all start dying because they're all starving. There's always limiting factors to any exponential growth. Hey, did you guys read about the goats that kind of helped save Reagan Library? Reagan Library? Mrs. Reagan. President Reagan. Anyway. Don't call Mrs. Reagan Mrs. Reagan, but you guys never had her. It's so sad.
I have her.
Anyway, coming back. How do we get into goats? Oh, logistic growth, because they eat the, anyway, coming back. So the flu, it's growing and then it starts leveling because, okay, everybody's sick, so, well, we're done. Okay. One student returns from vacation with a contagious and long-lasting flu virus. Great. We have a model. Cool. Why? You guys see how short this could be, right? What would the name be? Contagious flu virus.
Just flu virus.
Use that same. Anyway, dateline. Anyway, can't we just do like Y and a colon? Number sign, kids infected, awesome. T, colon, days after the infection started. And then isn't this kind of an important clue that all of us would care about if we were on that campus? Classes canceled? Okay.
Only 40%.
Well, we have a lot on the campus, right? And then they're thinking maybe it's time to quarantine at that point. Okay, what's going on in letter A?
How many students are affected after 5 days? So it's time.
So probably.
That's easy. Aren't I just finding this? Does that make sense? Days, time, 5. Plug it in. Got it. Hey, look at how easy this is. Doesn't your calculator have a really cool way of writing fractions that we talked about earlier?
Yeah.
Couldn't you literally put this entire, I'm using literally in the literal sense, so it's okay. Oh, no, T is 5. Can't you put this in your calculator and say, give me the answer, please? Yes. Nathan's going to do it for us because he's awesome and he's been plugging it in. Others of you back him up because you're awesome and you're making sure he's right. The only reason I want us to get an actual answer is because like the 19.06, we had to think about what it meant, not just stop. But then some of you might already be thinking of, okay, so what's letter B? How many days? I don't think we know time anymore, right?
Got 54.02.
Why didn't I put 0.02 kids are infected?
Because you can't get
Let's just say the symptoms haven't exactly manifested yet at this point 0.02.
Yeah.
And isn't this still kind of like a prediction, like it's a rough estimate, even though there's a formula? Life does not necessarily perfectly follow the math. Talk to anyone in the stock market. Anyway, so letter B. What have you guys thought about?
You have to find 40% of 5,000.
What's 40% of 5,000? Some of you are going to your calculators, so that's no fun. It's 2/5, and that's 2,000.
So now
Nice.
2,000 equals 5,000.
2,000 goes in the y spot. If we have all of our coefficients plugged in, it's easy. Either plug in x, find y, plug in y, find x. But why are they putting this at the very end of the exponential and logarithmic chapter? You guys see it, right? There's an agenda here. They're saying, hopefully, if you're in pre-cal, you're going to see math at some point. Hopefully, at least some of you are going into STEM-ish areas. Exponentials will be there. Logarithms will be there. Not all the time, but it'll show up. Hopefully, you have the skills to handle them when they do. Oh, gross. Is anybody else thinking that's disgusting, this all?
Yes.
Do you really want to do a y1, y2, play with the window? Maybe some of you would. Find the intersection. In calculus, we'll talk about how to make that a little bit easier. But, for right now. But is there a way to do the math? Why am I writing 1 plus 4,099 e to the negative 0.8 equals 5 over 2? How does that make everything a little bit easier? What math did I do, Emma?
You could simplify the 5,000 to 2,000. I don't know how you got there, but
You multiply.
Oh yeah, if they're over each other, all the zeros reduce. Dylan, yeah, I multiplied this up, and when I multiplied it up, what could I do with the 2,000? See it? So I multiplied my chunk, because remember, division messes everything up. I got rid of my division, like we've been doing a lot. I got rid of that constant. Sweet. Oh, sweet. Minus 1. That's easy. Minus, I'm lazy. I don't want to go to a calculator. I don't want to have to think about 2.5. I just make 1 into 2 over 2. Okay, that's easy. Now what? Why am I going to put a 4999 down there? Because I can divide everything, right? Now I have an e to the negative 0.8 t. T equals ln of 3 over 2 times 4999. End your logarithm. Divided by negative 0.
if we already have that equation, we're not going to start plugging in before we need to do the work.
You mean like how there's always an ln of a something over something? And problem is with this guy, do you see how something extra showed up?
Yeah.
I don't know if I necessarily want you memorizing, but I mean, you can have in the back of your mind, oh, I think I know what it's going to look like, just to make sure you're good. But if there's one little tweak in an equation, just be careful. But I get what you're saying, Emma. And that's the same reason why that whole doubling half-life thing is like, just memorize the formula for chem kids. Like, sometimes it's easier just to memorize and not understand the math behind it. Anybody get it yet?
I found it, but I don't understand.
Oh.
I got 10.14.
Anybody back from that? Kobe's checking. And you made sure that this was all in the division, right?
Yeah.
And the log was closed. Well, there were only 54 kids infected after 5 days. We needed 2,000. And it was exponentially growing, so remember, it was spreading faster and faster and faster. If that's where you're confused. It very well could be.
would make sense.
Because it's not just doubling,
Yeah.
right? Doubling would be like a line. Exponential goes way up, way quicker. What would the college actually do? You guys see the dilemma, right? Are they going to cancel at day 10, seeing that the trend is, okay, we're going to have 40% tomorrow, may as well cancel classes? Or are they the type of like, no, we're going to wait until that 2,000th kid gets sick? Let's just say 10-ish days, is that okay? You're starting to struggle just a little bit with the math can tell you one thing, but life, you kind of still have to make a decision. Did you get the same? 10-ish? Hey guys, that's the last example I have for you. Still have about 10 minutes, 5 minutes, 5 minutes. If you want to pull up Google Classroom or borrow someone next to you who wrote down the homework problems you haven't, totally fine. I can pull up the beginning of homework, but the tables kind of are the beginning of homework. You guys can go to the website and pull up the PDF version of the book. You can come borrow a book, but I realize there's not a lot of time left to class, right? We still get to be together tomorrow, right? No one's leaving for retreat until 11. Yeah, I get you guys. Let me see. I can show you the beginning of homework. Here we go. It's not going to help those of you that are farther along in homework, but let's be honest, most of you farther along in homework, we're kind of working on it during class anyway. It's not totally bad. It's a little dangerous, but most of you listen when you realize it's not. All you're doing is saying good old-fashioned algebra 1, get it by itself. Oh, fine. Okay. We don't have the information. Emma, what you were saying is kind of like what's going on here when you solve for t. Like for certain equations, if that's what's missing, you're right. It's going to be the same thing. For those of you that are just kind of like, you know what, it's pointless for me to try to start right now. I get it. It's fine. I have it up here if you want to try to start. But can we at least talk about a strategy since you're going on retreat, a lot of you, tomorrow? Now, I looked at the list, and quite a few of you are not going on retreat, so you'll have plenty of time. Not saying that you're not doing anything with your lives this weekend. I'm just saying you have more time than those that are gone Friday night to Sunday afternoon, whatever. We have a test next Tuesday. But check it. We're done with the last section today. I made it because of the retreat that we have 2 review days. Does that make sense? We have tomorrow and we have Monday, but wait, what else are we going to do tomorrow? Grade this nasty, beastly homework, right? The homework's nastier, I think, than the review, the section 3.5, and I think it's nastier than anything else in the entire chapter, and it literally covers, I think, half of the long answers, so like 2 long answers and maybe 1 multiple choice. So it's on the test. It's important, but I've been very specific about like PERT and about the money table. So, if you tonight get stuck, number 1, I would encourage you to try to summarize the key information and go as far as you can, then throw a big question mark, ask tomorrow. Tomorrow's going to be mostly a work day on 3.5. But couldn't you, especially my retreat people, couldn't you start playing with the review tonight? Because for your test, you're going to have to know basic things like the product property of logs or the change of base formula or, I don't know, quotient property, the inverse property, 1-to-1, what to do if you see an equation like, and please hear me. I was just talking to a friend from my small group last night. She was asking me, like, how do I get my 7th grader? Give me techniques for him to study for math because it's just starting to get hard for him, and it's been so easy. Some of you, it's been so easy, and now it's getting hard. Or it's been hard in Algebra 2, and you were never told or you never heeded the advice of you have to change how you study for math tests. Some of you are like, it used to be I could look at it and I could do it. This isn't like that. If you're looking at solutions being like, and then blanking out on a test, there's a reason for that. You're not internalizing it and making sure you have the skill developed. You're just understanding how it works. But there are tons of sports commentators that can understand how a game works and they could never do it on their own. True? Same thing with us. You can understand how it works and that's not going to help you on a test unless you practice. So please practice in 3.5. If you get stuck though, hear me. Most of 3.5 homework is harder than the test. So do the best you can. It's good. It's applicable for future anything you do in STEM. But go to your review and start playing with that. Is that cool? Especially my retreat people. Yeah. Yeah, sure. All right, guys, hang out. Check in with each other, see how you're doing. Maybe you're working and you're just going to like ignore everyone around you. But